Good morning all, I am Joyeta Moietree, and yes, today is the first episode of Fun to Explore from Thermal Physics. So yes, it is very predictable that in the first episode I'll be speaking about the first chapter from Thermal Physics, which is Simple Kinetic Theory of Matter. And basically this chapter is discussed in session 1 and session 2. The link of the session 1 and session 2 is given in the description box below, so if you have any confusion you can check it out. So let's review what we have learned from session 2 and session 1 before actually exploring something new and fun today. So when it comes to session 1 and session 2, we first of all learned about solids, liquids and gas. We not only learned about the list of properties of solids, liquids and gas, but we also learned how did they get their properties. Based on which certain arrangement or movements of molecules did solids, liquids and gas get the properties they have. And not only that, we also learned that why will certain arrangement or certain type of movement lead to that individual property. So we basically learned a lot. And we also learned, from session 2 we learned about the 3 gas laws. Which is Boyles Law, which is P1 V1 equals to P2 V2, Church's Law, V1 by T1 equals to V2 by T2, and Pressure Law, P1 by T1 equals to P2 by T2. So all these things. Now in this video we will basically explore something new and fun from the very basics that I have reviewed till now. So let's just review the basics of the basics. That is, before beginning thermal physics I have said something, that is, I am considering that you have some basic knowledge about the basic physics, which is these 3 equations. I have talked about it in the very first video, and at the last one I am again speaking about it. So the equation is density equals to mass by volume, pressure equals to force by area, and pressure equals to H rho G. These are the very basic ideas. It's not a part of thermal physics, but you need the knowledge of these equations to study thermal physics. So let's revise again. Pressure equals to force by area. This equation is applicable for every object, every matter. Whereas pressure equals to H rho G, it is only valid for pressure in liquids. Now with this idea in mind and our basic idea about simple kinetic theory of matter, let's explore something fun and new. What to explore? Any idea? Anyone? Well, if you can remember, in session 1, I have spoken about the properties of solids, liquids and gas. And while speaking about the properties, I have spoken about one term, that is compressibility. Yes, I have explained that solids, they are incompressible, liquids, they are not compressible, and gases, they are compressible. That is their property. And I have also explained using molecular arrangement or molecular movement that why are they compressible or not compressible and all these things. But today's fun explore will include, do you actually know what compressibility means? I mean, we understand why they are compressible or not compressible, but the thing is we don't understand what compressibility is. So today we will explore about compressibility. Compressibility basically means a change in volume due to a change in pressure. So when there is a change in pressure, if the volume of the substance also changes, then that substance is basically compressible. Now, using this equation, density equals to mass by volume, we understand that if there is a change in volume, then there is of course a change in density. Hence, due to a change in pressure, when a substance's density changes, that substance is said to be compressible. Now my dear, before some time I have said about Boyles Law. P1 V1 equals to P2 V2. Alright, very nice equation. This equation shows that when the temperature is constant, the pressure-volume relationship is inversely proportional. Which basically shows that if pressure changes, then volume changes. Then, of course, if pressure changes and then volume changes, then of course every substance in this world must be compressible. Then why did we say that solids, they are incompressible, or gases, they are compressible, and all these things? According to this equation, of course, every substance must be compressible because a change in pressure will cause a change in volume. Did I speak stupid things in my session 1 video, or did I give you some wrong knowledge? Are you feeling angry on me? Of course not, because you're feeling that I am a stupid speaking right now. What did I say? This is a part of gas law. P1 V1 equals to P2 V2 is a gas law, which means this equation of pressure is only applicable for gases. And for liquids or solids, P equals to H rho G. This equation is applicable for pressure in liquid. This equation is applicable for pressure in solids. Pressure equals to force by area. So we must differentiate the differences between pressure in different state of matter. Yes, we definitely know using our knowledge about molecular arrangement or movement that why certain materials they are compressible or not compressible and all these things, but we must explore mathematically as well that what does the mathematical equation say? What does the mathematical equation try to speak? Are they trying to speak to us? Are they trying to give us some information? So you see, these equations were just in front of us and we just did not really explore the equations. We knew all the three equations. We just apparently did the math when the maths came, when the values came. But it's also important to explore the knowledge using the basic knowledge we have. And yes, therefore I am done with my first video for Fun to Explore series. And yes, the next 4 videos will be coming because Fun to Explore will be having 5 episodes. So in those videos as well, we will explore this gap in our knowledge. That is, we know something, but there is more to explore. So yes, what to say? I'm just so excited to know your comments, how you felt watching this Fun to Explore series from thermal physics. And yes, I'll be back soon on the next episode with Fun to Explore. Until then, stay home, stay safe, stay cool, and stay tuned with Explore with Joyeta. Thank you.